There's a heating system that keeps a room warm for 3 full days from one fire. No electricity, no filters, no monthly bills, just stone, clay, and the oldest thermal engineering on Earth. A Korean temple built this system around 900 AD. Historical records describe its floor staying hot for 45 days from one single firing, warm for 100 days. Frank Lloyd Wright called it the only ideal heat. He brought it to America, credited Korea explicitly in 2 published books, and used it in 60 homes. Today, 90% of all South Korean homes still run on this technology. And a $200 billion global heating and cooling industry has spent 70 years making absolutely sure you never once heard the word Ondol. Welcome to Forbidden Camping. This is where we crack open the vaults the industry locks shut. If these stories matter to you, hit subscribe now and ring the bell. Every vault we open, you will be first. Ondol. The word means warm stone in Korean. The older, truer name is gyudul, baked stone, a name that stretches back further than most Western civilizations have existed. Here is what Ondol actually is. Fires lit in a firebox built into the kitchen wall. Not above the floor, not inside the room, completely outside the living space. The heat from that fire travels underground, through precisely engineered stone channels running beneath the entire floor. The stone absorbs that heat, stores it for hours, and radiates it gently upward through your feet and into every person in the room. No vents blasting air, no registers clanking, no noise at all, just warm stone beneath you in a room that holds its temperature from the floor up. The United States Department of Energy has confirmed in its own published research that this type of heating is more efficient than both baseboard systems and forced air furnaces. Studies from Lawrence Berkeley National Laboratory found radiant floor systems run 20 to 40% more efficiently than the furnaces heating most American homes right now. A 3,000-year-old Korean invention outperforms your furnace by the federal government's own measurement. Most Americans have never heard its name. Stay with me, because the story of how Ondol reached America and then vanished involves a stolen palace, a Japanese baron, and the most famous architect this country ever produced. And that story begins in a freezing Tokyo dining room in 1917, January of 1917. Frank Lloyd Wright is in Tokyo overseeing construction of the Imperial Hotel, the building he specifically engineered to survive earthquakes. He is invited to dinner at the private residence of Baron Okura Kiyachiro, one of the wealthiest men in Japan, the man financing the hotel project. 19 courses of food, a freezing formal room. And then, after dinner, the Baron leads Wright downstairs. Wright stepped into what the Baron called the Korean room. There was an indescribable warmth, no visible source of heat anywhere. He later wrote that the climate seemed to have changed, that it was not a matter of heating at all, but an affair of climate. The Baron's interpreter explained the system, a fire built outside the room, drawing heat back and forth through stone ducts beneath the entire floor. Wright called it a discovery, and declared there is no other ideal heat, not even the heat of the sun. Now here's the detail they left out of every American architecture textbook. That room was not just any Korean room. Professor Hyun-Sob Kim of Korea University spent years tracing its precise origins. That room was almost certainly the Joseondang, a royal building dismantled from Gyeongbokgung Palace in Seoul by Japan's colonial administration, shipped to Tokyo stone by stone and rebuilt on Baron Okura's private estate. The building that permanently changed Frank Lloyd Wright's understanding of heat had been physically taken from a Korean palace. Wright acted immediately, installing radiant heating beneath the bathrooms of the Imperial Hotel before the building was complete. Then he brought the principle home to America. In 1937, he asked a Wisconsin journalist named Herbert Jacobs whether he had ever heard of the Korean way of heating a house, and whether his family would like to become the first in America to try it. The Herbert Jacobs House in Madison, Wisconsin, now a UNESCO World Heritage Site, became the first American home heated from the floor up. Catherine Jacobs called it the most pleasant heat she had ever experienced. Wright kept building with this system for 20 more years, crediting Korea openly in every published account. He called it gravity heat in his workshop notes, a name that captured exactly what the system did, warming from the ground up. Those 60 homes quietly seeded something that would eventually warm over 28,000 American houses. But the way it disappeared is the part nobody teaches. Alfred Levitt was not an architect. He was a builder. In the late 1940s, his job was to build houses as fast as humanly possible for the soldiers coming home from World War II. He spent 10 months watching Wright's Usonian homes being constructed, wrote directly to Wright's studio requesting the heating system documents, and then used them at massive scale. Levittown, New York. 17,000 homes built between 1947 and 1951. Every single one heated with radiant floors, the Korean Ondol principle running through pipes embedded in concrete slabs. 17,000 American families warmed by a 3,000-year-old invention they had never heard of. Then, Joseph Eichler went further. Eichler had personally lived in a Wright house and understood firsthand what radiant heat felt like. He built over 11,000 California homes between 1949 and 1974. Every one of them radiant floors, 28,000 homes, one generation, all built on the Ondol principle, all warm from below, and then something collapsed, all of it. The pipes failed. The copper and steel pipes embedded in Levittown's concrete slabs began corroding from the inside, slowly at first, then completely. Repairs meant jackhammering up finished floors. Lawsuits followed. Eichler's California homes developed the same problem. Replacement materials also failed. By the 1970s, the phrase radiant floor heating had become synonymous in the American construction industry with cost overruns and litigation. But the damage went deeper than money. The forced air systems filling those homes came with a problem nobody was measuring. When air is pushed through ductwork inside walls and above ceilings, it carries everything living in those ducts directly into every room. Dust, mold spores, pet dander, and airborne allergens circulated on every breath of heated air. Research has since documented up to 80% fewer dust mites in buildings with radiant heat versus forced air. Korea had been breathing clean warmth from stone floors for 3,000 years. America switched to a system that heated the air and everything living inside it. At the same time, post-war construction demanded speed and cost minimization. Forced air ductwork installs fast, a fraction of radiant's price. And starting in the 1950s, central air conditioning became standard across America. Here was the decisive moment. If you already had ducts installed for cooling, adding a furnace to those same ducts for heating cost almost nothing extra. Forced air did two jobs. Radiant did one. The entire American heating manufacturing industry, its training networks, supply chains, and building codes organized themselves around one technology. Forced air won, not because it performed better, but because it was cheaper to install and bundled with cooling. Wait, here is what those forced air systems are actually doing to your heating bill every single month. The United States Department of Energy states that forced air duct systems lose between 25 and 40% of all the energy they produce through duct leaks before heat ever reaches the room. That is not a fringe study. That is the federal government's own published number. You are paying for 100% of the heat your furnace generates. You are receiving, at best, 75% of it. The rest is heating your attic and your crawl space, and you are billed for all of it every single month. Modern radiant systems lose almost nothing. A condensing boiler paired with radiant floors achieves 90 to 98% fuel utilization. Water carries thermal energy 3,500 times more efficiently than air. This is physics. It cannot be debated away. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, the body that writes the standards your building codes enforce, has confirmed in its own research that human beings exchange over 50% of sensible body heat through radiation. We are not biologically designed to be heated by hot air blown across a room. We are designed to be warmed by surfaces. The Korean engineers who built Ondol 3,000 years ago understood human physiology better than the forced air industry of 1950. Here is what Ondol actually looks like from the inside, because this is the knowledge the heating industry has needed you to never have. The traditional system has 5 precisely calibrated components. The agungi, the firebox, sits in the kitchen wall, built 2 to 3 feet lower than the living floor. That drop forces the flame to travel horizontally underground rather than upward. The fire never enters the room. From the firebox, hot gases move through the gore, stone channels roughly 12 inches wide and 12 inches tall, running a slight upward angle beneath the entire floor. Those channels split at the entrance, distribute heat evenly across the full floor surface, and converge near the chimney on the far wall. Large, flat slabs of granite and mica-bearing stone sit above those channels, absorbing heat and releasing it slowly, radiating warmth upward through a sealed clay and paper floor surface for hours after the fire goes cold. One fire, 8 to 12 hours of warmth in a well-built system, 30 centuries of Korean winters, heated this way. The most documented example is the Ajabang room inside Chilbolsa Temple. Historical records describe its floor staying hot for 45 days from one single firing, warm for 100 days. The modern reconstruction, rebuilt in 1982 after the original was destroyed in the Korean War, still retains measurable warmth for 10 full days in spring and 3 full days in deep winter, even when outside temperatures fall to 14 degrees Fahrenheit. Now connect everything back to where we started. Wright walked into a room that used this technology, a room physically removed from a Korean royal palace and rebuilt on Japanese soil, and called it the discovery of his career. He brought it to America, credited Korea openly in 2 published books, and watched the principles spread into 28,000 homes across 2 decades. Then, the pipes corroded. The duct installers were faster. The cooling systems already needed ducts. The market calcified around what was profitable, not what was optimal, and 70 years of institutional inertia did the rest, not a conspiracy. An infrastructure lock-in that made a superior technology economically invisible. The Korean government designated Ondol as National Intangible Cultural Heritage on April 30th, 2018, formally recognizing that a technology 3,000 years old remains in active daily use across the country that invented it. Researcher Robert Fauser at Sogang University described the situation precisely. Unlike K-pop or kimchi, underfloor heating is rarely associated with Korea, even as it recaptures the global market. The global radiant floor market reached $4.6 billion in 2024. It is projected to reach $8.5 billion by 2033. North America is now the fastest growing region at 7.1% annually. Germany, Denmark, Austria, and Switzerland install radiant floors in nearly half of all newly built homes. The rest of the world has already figured this out. America is only now catching up. What was buried was not a secret. It was simply not profitable enough to teach you. Forced air generated more revenue per installation, so the industry taught installers forced air. And the Korean origin of the warmest floor you will ever stand on disappeared from every catalog, every textbook, and every building code that followed. The floor beneath you right now is likely cold around the edges, heated if you are lucky, by ducts pushing air that loses a third of its energy before it ever reaches the room, running on a system whose fundamental design has not changed since 1950. The next time you step onto a heated floor somewhere and feel that specific warmth, the kind that rises through your feet and stays with you, you are feeling something Korean families have known for 30 centuries. Ondol, warm stone. If this vault opened something for you today, hit subscribe and share this with someone who pays a heating bill every single month. And if this story surprised you, wait until you see what we open next time.